Expectation and variance. So here's a problem from Alex. You're looking for expectation and variance of a random variable. This is from the binomial distributions section of your pie. So here we have a probability distribution. We're given, this is the title of that topic, okay, expectation and variance of a random variable. So here we have a table. We're given some values of x and the probability that each one will occur. And you'll notice that these all add up to 100% or 1.00. All probability distributions, the probabilities of those have to always add up to 1. So we're asked to find the expectation and the variance of our variable x. Well, there's a process. The first thing we're going to do is to note that the formula for expectation is this. It's not as ugly as it seems. It really is just the first x times its probability, the probability that x is this particular number. So first we have 0 times 0.30. Then the next one says x2 times the probability that x is equal to x2. Well, that's just 10 times 0.10. And so on for as many as you have. In this case, we have 4. So n is 4. So x sub 4 times the probability that x equals the fourth value, which is 30. So multiplying that all out, the expectation is 0 times 0.30 plus 10 times 0.10 from here, plus 20 times 0.05, plus 30 times 0.55. 0 times 0.30 is 0, 10 times 0.1 is 1, 20 times 0.05 is also 1, and 30 times 0.55 is 16.5. Add them together, you get 18.5 as the expectation of this probability distribution. Okay, so that is the product of each x times its probability, and in the end you add them all together to get the expectation. Okay. Oops. So here we have, the question is, what is the variance of a random variable? So I've got the same distribution, and the question is for the variance. Okay, and that is the topic in Alex. What is the variance of a random variable? So here's the formula. The expectation of x squared minus the expectation of x, and then squared. The formula can also be written out in a huge, long, ugly way, but this is a condensed version of it that works quite nicely for us. So the first thing that we need is to find x squared. So we're going to go through each of the, there we are. We're going to go through each of these values and square it. So 0 squared is 0, 10 squared is 100, 20 squared is 400, and 30 squared is 900. Well, the first thing that came up is the second part, is the expectation of x, which was from the earlier thing, problem that we just did. Now, my animations are in the wrong order. I didn't notice that, and I'm not able to fix it at this point. So the first thing we really want to find out is expectation of x squared. So on the x squared, we're just going to multiply the 0, which is in the x squared column, times 0.30, and then 100 times 0.10, and then 400 times 0.05, and 900 times 0.55, which is just the expectation formula being used with the x squared values. So multiplying these out, 0 times 0.30 is 0, 100 times 0.10 is 10, 400 times 0.05 is 20, and 900 times 0.55 is 495. When you add those all together, you get 525. Now the formula says the expectation of x squared. So the expectation of x squared here was the 525. The expectation of e of x, and then squared, 18.5 and then squared. And when you work out this little multiplication, you get 182.75 is your variance of this probability distribution. Remember that these x squares you've got to put in yourself in order to calculate this. Are there any questions?